If the hottest room in your house turns into an oven every day, the problem may not be a weak air conditioner. You may be trying to cool heat that should never have entered the house in the first place. Traditional Japanese houses were designed for long, humid, and stifling summers. Their walls were lightweight, the rooms were open, and instead of powerful equipment, they used a sequence of simple solutions. First block the sun, then create a path for the air. After that, cool the surfaces, and finally, trap the coolness of the night inside. And the most interesting part is that most of this system can be recreated in an ordinary American House 8 without rebuilding the roof or buying expensive equipment. Today, I will show you 7 Japanese cooling principles, but this will not be a list of random life hacks. We will follow the path of heat from the street to your bedroom and block its next route at every stage. One of these methods costs about $20. Several cost nothing. And the last one can make the walls, floor, and furniture act as a reserve of coolness for the next day. But do not start using all of them at once. By the end, you will understand which one you should use first in your own home. The first principle is not inside the room, but outside the window. In Japan, sudare and yoshizu were used for this purpose. Lightweight screens made of bamboo or reeds. They look almost decorative, but they do a job that indoor curtains begin doing too late. When sunlight passes through the glass and heats the floor, table, or sofa, those surfaces begin releasing heat into the room. You can close the blinds from the inside, but the solar energy has already crossed the glass. An exterior screen intercepts it earlier. That is why the U.S. Department of Energy recommends exterior shading as one way to reduce summer solar heat gain. A modern version of sudare is a roll-up bamboo shade, solar screen, or light-colored awning above the window. But do not cover the whole house at random. First, find the window that becomes difficult to stand near in the afternoon. Most often, it is on the west side. Hang the screen outside, leaving a small air gap between it and the glass.
Then
the heated material can release part of its heat into the outdoor air instead of into the window. This solves the problem of direct sunlight. But the window is not the only surface that heats the room. Sometimes the real furnace is directly behind the glass. Look at a traditional Japanese house. Between the garden and the living room, there is often a narrow wooden veranda called an engawa. At first glance, it is simply a place to sit and look out at the yard. But in terms of temperature, the engawa works as a buffer zone. Sunlight first reaches the roof overhang and the veranda before it gets close to the interior room. In an ordinary house, a covered terrace or an awning can serve a similar purpose, as can a shaded porch or even a temporary fabric structure in front of the hottest facade. The point is not to create a beautiful Japanese veranda. The point is to prevent the sun from heating the wall and glass for 6 or 8 hours in a row. A hot wall continues releasing stored heat even after sunset. That is why some rooms become especially unbearable not at noon, but around 9 in the evening. Try a simple test. During the day, touch the outside wall of the house, first in direct sunlight and then in the shade beneath an awning. You will feel the difference immediately. Anything that creates permanent shade in front of a west-facing wall reduces the amount of heat you will need to remove in the evening. And the result is easy to check without special equipment. Leave one section of the wall exposed and shade another section for several hours. Then compare them with your hand or an ordinary infrared thermometer. You will see not a pretty theory, but a real difference in how much solar energy each surface has stored. Now we have stopped some of the heat before it entered the house. But even a shaded room can remain stuffy if the air inside is standing still. And this is where most people make the same mistake. They open the nearest window and wait for a breeze. A traditional Japanese house worked differently. Sliding partitions made it possible not only to let air in, but to create a route for it through several rooms. An air needs an entrance and an exit. If only one window is open, the airflow often circulates near the opening and barely reaches the far side of the room. But when a second opening appears on another side of the house, the outdoor pressure begins pushing air through the interior. Tonight, do not simply open the bedroom window. Open the bedroom door, then open a window in the opposite room or at the end of the hallway. After that, stand between the two openings and slowly narrow one of them. Sometimes a narrower inlet creates a faster airflow than two fully open windows. But there is one important rule. You should open the house only when the outdoor air is cooler than the indoor air.
Wide open windows let in hot 96-degree air. The house stays hot, despite being cooler inside.
Wide open ventilation will not cool the house. It will fill it with hotter air. In a few minutes, I will show you a simple way to determine the right moment without guessing. Meanwhile, if you enjoy practical technologies that reduce your bills and do not require complicated equipment, give this video a like and subscribe. Here, we do not discuss tips just for the sake of tips. We explain the physics that makes them work, so the horizontal airflow is now moving. But what can you do on a completely windless evening? Japanese builders used more than side-to-side air movement. They also used the natural tendency of hot air to rise. If cool air enters through a low-shaded window, warms inside the house, and is given a higher exit through a second-floor window, stairwell, or upper ventilation opening, the stack effect begins. The house starts pulling heat out without a fan. In a modern two-story house, try opening a small first-floor window on the shaded side fifth and a higher window upstairs. The interior doors along the airflow path must remain open. If you have a one-story house, properly designed attic ventilation can sometimes serve as the upper outlet. But do not open the living space directly into a dusty or overheated attic. The airflow must leave outdoors through a safe, separate channel rather than bringing attic air back into the house. Now the air is moving through the rooms and rising upward. But there is another surface that modern houses often ignore: the floor. In many old Japanese houses, the living area was raised above the ground. This protected the wood from moisture and allowed air to move beneath the floor. During hot weather, the shaded space under the house could remain cooler than the exposed ground around it. You cannot raise an existing American house, but you can apply the same principle around the foundation. Do not allow the sun to overheat concrete, stone, or dark soil directly beside the hottest window. Light-colored gravel, vegetation, a lattice screen, or shade from an awning can reduce surface heating near the house. Pay special attention to the air conditioner. If its outdoor unit sits in a tight corner surrounded by hot concrete and without free airflow, it operates under the worst possible conditions. You can shade the surrounding surface, but you must not cover the unit itself or block the discharge of hot air. We have blocked the sun, created horizontal and vertical airflow, and reduced the heat around the house. But by evening, the walkway, yard, and terrace may still be releasing the heat they stored during the day. This is where the Japanese practice of uchimizu comes in, lightly wetting the ground or a paved surface with water. As the water evaporates, it draws heat from the surface. But timing is everything. If you pour water onto a scorching walkway under the midday sun, most of it will disappear too quickly. It is much more effective to lightly wet a shaded area late in the evening, when the sun is no longer adding heat back to the surface. Use a small amount of water instead of turning the yard into a puddle. Do not use salty or contaminated water near plants. Evaporative cooling is more noticeable in dry climates and weaker where the air is already saturated with moisture. This will not cool the entire house like an air conditioner, but if evening air enters through a window above scorching concrete, cooling that surface can make the incoming airflow more comfortable. And now we have reached the strongest principle. All the previous methods help only partially if the house remains open at the wrong time. Traditional summer life in Japan followed the daily temperature cycle. The house was opened when the evening coolness arrived and protected when the sun returned. Today, this is called night ventilation. 68_1. Place one inexpensive thermometer indoors and another outside in the shade. Do not open the windows simply because the sun has set. Wait until the outdoor temperature actually drops below the indoor temperature. At that moment, open 2 distant windows and the doors between them. If the house has 2 stories, add a high outlet. The night air will do more than cool the rooms. It will gradually draw heat out of the floor, furniture, and interior walls. In the morning, do the opposite. As soon as the outdoor temperature begins approaching the indoor temperature, close the windows, exterior screens, and curtains on the sunny side. The house must switch from ventilation mode to preservation mode. In dry regions where nighttime temperatures can be 15 or 20 degrees Fahrenheit lower than the daytime high, this principle can work especially well. In humid regions with warm nights, the effect will be weaker, and when air quality is poor or pollen levels are high, it is better to keep the windows closed. That is why there is no single Japanese trick that works for everyone. There is a sequence, and if even one of these principles was new to you, click the subscribe button. In future videos, we will continue exploring old building solutions that can reduce a home's dependence on expensive technology. Write in the comments which part of your home gets the hottest: a west-facing room, the second floor, the bedroom, or the kitchen.